So hello and welcome to what I'm boldly going to call our monthly Hydrographic Society in Scotland and Norwegian Offshore Survey and Positioning Forum joint live event. My name's Simon Canning and I'm the chair of the Hydrographic Society in Scotland. And our evening is entitled Remote Operations, the Next Steps and Future Challenges for Uncrewed Survey Operations. So before we get underway, I'd like you to note your comments section on the YouTube screen. And as usual, this is the way we'll be asking questions. So nominally use the comment section for chat and all that sort of stuff as usual. But please do remember to ask questions during the presentations. And then at the end of the presentation, I'll ask those questions on your behalf after I've collated them as we go along. So, without further ado, our first presenter this evening is Matthew Garrett. He's a surveyor at BP. Welcome, Matt. Matt's a surveyor and part of the global survey and positioning team at BP. He started his career as a land surveyor and joined BP 9 years ago. Since then, he's supported a variety of global projects. He's currently based in Aberdeen, supporting the North Sea region, and is managing the annual site survey campaign. And Matt's presentation this evening is entitled Remote Operations, How Refocusing the Business Has Helped Embrace the Technology. So thanks for joining us, Matt, and over to you.
That's great. Thanks, Simon. Thanks for having me. Good evening, everyone. Yeah, thanks for having me as part of this evening event. It's great to be here and to talk to you on this topic tonight. So really what I'm here to do now is to give a very high-level overview of what's been going on within BP in relation to remote operations, and really just to try and set the scene for the three other great presentations that we've got lined up this evening. So really just to start, I want to ask the question, why this update? Why is it important to hear from us as an operator and an end user? I think for the past number of years, we've seen a huge development in the world of remote operations and remote support. And back when we could all travel to events and conferences, we were seeing firsthand that the technology came through and also continues to develop at a fantastic pace today. But I think for technology and its deployment to be successful, as well as needing the great innovations and the support infrastructure, we need the end users to buy into these technologies and to adopt these ways of working. It not only makes these techniques more viable, but it also drives the future development, as well as giving those on the development side more support for the challenges that they face. So we can attack these things on two sides. So for the next 10 minutes or so, I'm just going to give you a real high-level view of BP's journey into remote operations, show you where we are now, and highlight really what we see as the next challenges and how we're looking to help overcome these. So to start with, I just want to wind the clock back a few years to 2018, although that does seem a lot longer than a few years ago at this current time. It was a time when we could all travel freely and meet face to face. But within BP at that time, our individual survey teams were embedded into individual regions. And up here in the North Sea, we had a team of 2 providing that survey support. From our team, we could see all these technologies coming through at events such as this and going to conferences. But on the most part, when we were discussing these internally, we were faced with these sort of comments on the screen. And I'm sure that most of you that are logging in tonight will be familiar with these as we talk new technologies. It can be a frustrating cycle. However, we were able to make small progress in sort of 2018 and 2019. We were able to look and trial some remote rig move processes for our North Sea. we were also able to execute a couple of short over the horizon operations for some data harvesting, and there was a push across companies to look at faster pipeline inspection techniques. These initial projects were great in laying the groundwork for our implementation of remote operations, but for the most part it was few and far between. And then, as we all know, 2020 happened, and everything changed in 2020, as I'm sure we can all appreciate. But even before we were seeing the huge impacts to our daily lives of COVID-19, here at BP, we were undergoing massive change from the start of the year. In early Q1 2020, we had our new CEO take up the reins, Bernard Looney, and very quickly after that, he made a huge public announcement around changing the entire strategy of the company to focus in on net zero ambitions, and also to make the switch from an integrated oil company to an integrated energy company. These new aims and ambitions were going to be underpinned by a global restructuring and a refocusing of the business to align on these net zero principles. That plus COVID-19, I can sit here now and say it's been a rough process, and I'm sure I'm not the only person to be sat here thinking that's happened to their companies as well. But as was said last year, the whole structure of this company has changed, and there is now a real clear internal drive to look at new opportunities. And that's not just for major projects, it's also for new improved ways of working, whether it be individual surveys or even just working on normal office type tasks. This new focus, along with our survey team being brought together into an integrated global team, has given us a much greater visibility of the work that we do, and has led us to be able to push these remote technologies forward. And now in 2021, we're beginning to see those rewards. So if I flick on now to looking, as we sit here almost halfway through 2021, with a real high-level snapshot of what we're seeing here in the North Sea, but also globally. It's also worth noting, before I just dive into a few details, that some of these tasks, and this is not an exclusive list of what's going on, some of these are being driven by survey, and from our interactions with many of you on this call, but also they're being driven by other people in the business. And that is a real exciting point where we're seeing non-survey parts of the business wanting to get behind these technologies and investigate ways that they can help them. So just to quick high level on what's really going on at the moment, starting here at home in the North Sea, we've got fixed wing drones being deployed offshore with sensors that are there to detect levels of methane on our assets and to help monitor that with an aim to reducing methane emissions. We are developing tracking apps to monitor our live operations by bringing in live position data strings from vessels, which allows us to track real time in the office the progress of our operation. We also now have scripts that combine that to be able to read specific information out of DPRs and bring all that into a single web browser and web app, which gives us a much greater insight into what's going on offshore, but also allows us to more easily share that information back with our internal stakeholders. Here in the North Sea, right at this moment, we are conducting the first kind of regional remote survey operations of actual collecting survey data. We're collecting over 800 square kilometres of bathymetry for a number of projects in the UKCS, and that's a big step forward from the initial small data harvesting jobs that we were doing a few years ago, and that's a really exciting place to be in. And as well as that, in the region, we're seeing our offshore teams embracing remote operations, remote technology by developing digital twins for the installations, by by using photography and digitized photography with background databases to be able to make decisions and measurements and see how the asset is aging and faring from the office. But it's not just the North Sea. We are seeing the take-up of remote technologies and operations globally. We are seeing other remote survey operations around the world. And one of the real strong points of our new organization is the ability we have in our global survey team to share our lessons and our operations and drive the success and those learnings to really implement these operations globally. We're also looking away from the survey front, but actually how do we conduct oversight and QC of this data remotely? This one is really being driven by the COVID-19 restrictions we're seeing as it has been hard to get people in and out of countries. So a real focus globally on how we can provide our oversight to operations remotely. And then a real higher level, just two points to end on there. There's now a global working group that is set up that's looking at these remote and autonomous survey solutions. They're looking to form a global strategy going forwards. And also, we're not refreshing existing contracts, but as we see projects arise, or we are at the point of renegotiating contracts, we are actively looking to include requests for remote operations, and that is a drive centrally and globally to do that. Unfortunately, I can't go into many specifics on much of those items today, but it is an exciting time as an end user, as a client on these, that we are now seeing these come through into the business. I'm hopeful that at some point we'll be able to share some specific project information in a session like this, but unfortunately that isn't today. So as we all start to emerge to our new normal, to coin a popular phrase at the moment, I wanted to quickly revert back to this slide and just show you what the new normal looks like in BP as we're coming out of COVID and a big process of change. We are now being actively challenged by management, not just survey management, to see how we can work differently. There is still a question of cost, as there is to any operation, but the follow-on questions that we now see all relate to, can we do this differently? And the key questions that relate back to the new strategy of the company are always around reducing HSE exposure, but now the key one around reducing CO2 emissions. And that is where a lot of these remote processes, technologies, survey operations play a part and really enable us to get after them and start using them. Now, this list of benefits on the screen won't actually be a surprise to many of you here tonight, because you will have been telling us these benefits for many years. But it's worth sharing because from our side, there is a new key point to these benefits, in that the middle one there is that remote working is no longer an alien concept to management. We've all now been working from home since March last year, and management across the globe has seen that actually removing people from our offices doesn't affect the day-to-day running of the business. And so when we go to them looking at remote operations, whether it be surveys or other such ideas, that idea of it being remote and unsighted is not scary or alien. So we are actually seeing a better buy-in on the back of COVID-19. And also, as I said before, with the refocusing on a zero carbon future, we are also able to focus on these benefits of cost and operational efficiencies, focusing in on net zero and lowering HSE exposure. It is a good position to be able to push these internally, and I think it does help us be in a position to engage with the suppliers and the developers in helping overcome what challenges we now see to really make a step forward in these operations. So just want to end up by highlighting 3 kind of real high level challenges that I've picked out that I see from a client perspective that we're going to be looking at in the near future. And I think the following presentations will be able to shed some light on these. But I just want to give you my few thoughts to kick us off. But the first one is actually an internal one around marine assurance. We, and as I'm sure the other operators and clients who may be on this call, have quite rigid requirements of vessels that come on to do work for us. And as we start to move towards remote survey, we're seeing that a lot of those requirements aren't really valid, as they are linked to safety of those on board and potential consequence of collisions to those on board. And those incidents have a lower threat with smaller vessels with no people on it. So internally, we need to realign our intake processes to allow these vessels to come through and do work for us. We have started work on this, and it is still a work in progress, and I imagine it will take a number of projects to get it right as we work through with suppliers to start looking at that. The next one is regulations, and I think this has been spoken about before, and it continues to be spoken about. But I just want to focus a little bit on the environmental regulations in terms of following consent conditions and sound mitigations for marine mammals. As an operator and a client, we tend to apply for these consents. So it means we can now be part of those conversations to make sure that we can see guidance that is fit for purpose, both for the marine mammal safety, but also for the operations, and to be an extra voice in the room as we look to do marine mammal observations potentially remotely, and how we can look to prove that is a viable way to keep the processes and the regulations that we have fit for purpose. And the final kind of big challenge that I can see going forward is looking at data QC and oversight. And I think for us, this is one of our big unknowns at the moment. As doing survey operations, we would normally have a person that would be representing BP to oversee the operation, but also to have a look at the data and to QC it as it comes in. So with all personnel coming on shore, that changes that focus. So there's going to be a big focus on bandwidth, and also an interesting look to see what happens to those personnel. Are we going to see QC reps sitting at home looking at data coming straight into their houses, or are we potentially going to look at bringing that into the office to do in-house? Again, I don't have the answers, but these are the sort of things that we're now starting to have to ask ourselves as we start to see more remote operations come on stream, and we start to push that more internally. So that's really all I wanted to say tonight. I hope that's been a useful little insight into life on the other side, as it's sometimes referred to. It is exciting for me to be here to share that we are actively getting involved in remote operations. And hopefully we can now provide a bit of a stronger voice in taking the next steps in these remote journeys that we're all on. So I'm looking forward to hearing what everyone else has got to say as we hopefully dive a bit deeper into some of these challenges. So that's it from me, and thank you all for listening.
Thanks, Matt. That was fantastic, and a real good insight into, as you say, what goes on the darker side of the business. So got a couple of questions. We have a question from Nikki Nichols over in Ellen. It's a question about your, I guess, your remote survey, your 800 square kilometres, I think it was. Was your remote survey data collected using a combination of ASV and AUV?
So at the moment, we're ASVs only. We haven't looked at sort of, well, we're looking in early talks about AUSV, AUV combos, but at the moment we're purely from surface vessels for those survey operations this year.
Okay. And we've got a question from Damien. How have your internal processes, i.e. data workflows, currently been adapted to integrate remote operations?
So yeah, that's one of our key questions as well, Damien. It's something that actually we're actively working. I think we've got quite the answer to it yet. I think as we get more experiences and start to use the actual the ASVs for surveying more often, we'll start to nail it down. I think the piece around the data QC kind of relates to that question, and it's something we haven't actually got an answer for yet. And I think at the moment we're seeing how we go, and it's almost we need to start using it to see where our gaps are, and that's the only way we're gonna make progress. So I haven't got a great answer to that, unfortunately, Damien, but it's really a trial and error sort of situation to get it right.
So you're learning by doing, effectively.
Essentially, yeah. I think that's the only way to do it at the moment is to dive in and start using it, because the technology is there. So we need to get on board and start using it.
Yeah, exactly. Okay. I've got a question from Imran. What can we do as surveyors to prepare for and also to help the transition to remote surveying? Let's do that question first, Matt. So
well, that's a great question.
It is, yeah.
Yeah. That's probably going to require more than my brains to answer that question, to be honest. But I think from our experiences as sitting mainly in offices, as I said, I think on the previous question is, we need to start using it, because I think until we get to a point where it's more commonplace, a lot of these answers will start to come through. And I realise that does sound like a bit of a cop out of an answer, but I think there is a lot of unknown, especially from the client side, as to how this will work. So it's, I think, prepare to just to dive in is kind of these are not great answering the questions, but we're just starting out and trying to find our way.
Yeah, exactly. You're just starting out. You've got to learn as you go, and develop new processes. And I guess that surveyors and engineers and anybody else who works in the business will adapt with the technology, I guess.
But I guess from a data point of view, there's no major changes. It's just where you're looking at the data. So from a purely technical survey point of view, that isn't changing. It's just, I think, understanding that if you're sat in an office, it's just as valid as being sat on the boat for purely seeing the data coming through.
Yeah. Another good question from Imran. I mean, he's out to bamboozle you this evening, I think. Do you foresee a survey standard for remote operations?
I would envisage, knowing how we tend to operate, that we would have something potentially internal. As I said, around the marine assurance, it's something from our intake that we do need to change, and we do, as a company, try to standardize our standards for different operations. So I would imagine at some point we would have something, at least at a high level, that would allow us to be consistent across the business, and to make sure that actually the data that we're getting is just as good as what we would do from a normal traditional survey vessel. So I don't know whether there'll be something globally cross company, but I think certainly internally it will be something that will probably come out of this over the next few years.
Okay, thank you. Excellent. So we've got another couple of questions coming up for you, Matt. Another one from Damien. Have remote operations changed the commercial landscape? i.e. geospatial data as a service?
So without going into too much detail, I think there are some changes in commercial aspects of this as we go to it, and I think data as a service is one of them, and we do interact with some suppliers on that basis, but others that we are we have been in contact with are not that, and more along a sort of traditional lines. I can't really say too much without our legal team jumping to me, but I think again, it, and that also is interesting, that data as a service does the QC part as well, and how you manage that that QC element, if it is a sort of what's a better phrase, as a data purchase, data as a service type agreement. So there are subtle changes in the ways of operating, and again, they can all be managed, but there are, we are seeing some subtle differences, Damien, as we sort of engage with more and more suppliers.
Okay. We've got a question from Vito. What are the biggest challenges regarding rough seas and metrology issues, if you've come across any of those, Matt, with the remote operations?
So unfortunately, I've not got personal metrology experience with these, so I'm not going to be able to answer that. But from a rough seas point of view, again, I think it's the size of the ASVs that you're looking to use. I think as expected, smaller units will struggle more in really rough weather than bigger units. But again, it's all looked and built in at the early stages of sort of planning and commercials, and we generally look to survey through some months anyway. But we're not seeing a massive impact on weather in what we're doing this year. But it's, if you're concerned, then it's probably a vessel size question, I'd imagine. But it's nothing too concerning that we've seen so far.
Okay, thank you. I've got a question from Matthew Kowalczyk. One of the biggest obstacles that we've seen is contracting mechanisms. I guess the legal team's ears will be pricking up now. Has BP addressed this problem so that smaller companies that are not part of the BP procurement system can provide services?
Yeah, so I can't talk too much in detail, unfortunately, on that, but we are seeing a more regional approach, I guess, to some of the contracting that we're doing. I think we've in the past we've had some big global agreements on sort of traditional services, and I think going into this sort of new space, there are a lot of different technologies and ideas. So even looking at the drones that we've got doing our methane work, I don't know the ins and outs, but they will be a very specific supplier for that. So I think we are getting to a stage where if we see something that is of use for us to do, there is a mechanism to bring them in, which is probably a slight difference to where we were a few years ago. Okay, I think that was vague enough, so legal won't hang me.
Yeah, I can't see any alarm bells ringing anywhere at the moment. I can't hear anybody knocking on your door anyway. Okay, got another couple of questions, Matt. One here from Hannes. Referring to the status quo of survey, where do you see the greatest change management coming in when running remote operations, i.e. quality assurance and repeatability?
The greatest change, I think the greatest change from a client point of view is probably going to be the quality assurance piece. And it's something, as I said, we would do that semi-live on the vessels with a person to sort of oversee the operation, and removing all personnel and from the operation, both from our side and from the survey, the vessels side, I think poses us some some questions in how we go about that process to ensure that the specifications we have for different surveys are being met. Again, it's something we've not nailed down. We know there are options out there where we're looking at companies having sort of remote hubs or data centers in various offices. So it's almost a case of you use those as it were a vessel and you go down, or whether you could see snippets of data come through. But there's probably that versus a bandwidth question is probably the biggest one for us is how we maintain that oversight as a client to what's being done.
Fabulous, thanks, Matt. Last question, but not least. I've got some questions myself, but I wanted to be greedy, but I'll ask the questions from the audience really, okay. And I think this will be a good subject to revisit as well, to see how you've progressed and stuff. But aside from my gripes, last question for Matt here from Mike King from Ocean Infinity. So you had a list of benefits there, Matt, of remote operations. Which of the benefits would you consider to be the primary driver? Is it HSE? Is it cost, or is it emissions?
So I think, in all honesty, it will still be cost as the primary driver. I don't think we'll ever get away from that. But we are seeing a bigger conversation around the HSE reduction and the CO2 reduction. So it's almost becoming a combination. I think if we're seeing different options that are very similar in cost, then I think actually that the HSE and CO2 does come into a big part, and it's becoming a really big driver for us internally, and that message is going up the food chain. So I would say I don't think we'll ever get to a stage where cost doesn't come into play, because at the end of the day it is a business. But we are seeing more of a conversation. It's not just do your reviews and whichever comes out the cheapest with obviously the technical solution, then we'll go for it. There is more of a conversation around, can we do this differently? Is it safer? Is it reducing the CO2 emissions? Because we are seeing a bigger drive internally about those ambitions coming through. So yeah, the three as a combined are probably the way forward. It's hard to verbalize that really, but it is more of a combined than it used to be, sort of one after the other.
Fantastic. Okay. So, like I say, it'd be interesting to revisit your journey at some point and see how things have progressed. And I guess same for this whole subject this evening. So, unfortunately, should I say, we haven't got time for any more questions for Matt. That was fantastic, Matt, and thanks very much for joining us and taking the time out to present this evening. It's very much appreciated.
Great. No, thanks for having me. It's been great.
Pleasure. Okay, so we have two presenters up next. We have Michael King, Senior BD Manager from Ocean Infinity, and we have Shabnam Hanif, Offshore Business Line Director at Ocean Infinity. Welcome, guys. I'll just give everybody a quick intro, quick run through your bios so we know who we're watching. Mike's first up on the list. However, I'll switch to Shabnam out of politeness. Okay, so Shabnam has a postgraduate qualification in psychology, initially starting her career as a clinical psychologist in Edinburgh, helping and supporting young adolescents. Finding a new passion in corporate growth and development, Shabnam joined the energy industry in 2010 to head up the data division for a consultancy offering geology and geophysical support. In November 2020, Shabnam joined Ocean Infinity as the Global Offshore Business Line Director, assisting with various marine projects and supporting clients in their transition towards unscrewed technology for safer offshore operations with a lesser environmental impact. Michael King, as I say, Senior Business Development Manager at Ocean Infinity, with a technical background in geophysics. With a technical background as a geophysicist. Michael started his career working offshore in oil and gas exploration, working all over the world. This was followed by a move into project management, where Michael gained extensive experience across a range of oil and gas projects, the offshore renewables sector, and the subsea cables market in the UK and Europe. More recently, his focus has been on business development and innovation, responsible for providing strategic commercial support and insight, with particular concentration on unmanned systems and their applications. So Michael and Shabnam's presentation this evening is entitled Unscrewed and Remote Operations, the Challenges of Marine Regulations and Communications and Data Transfer. So thanks, guys. Who are we kicking off with first? Or are you both on together?
I'll start. Okay, thanks, Simon. Hi everyone, good evening. As Simon said, my name is Shabnam and I'm the Offshore Business Line Director at Ocean Infinity. So I'm going to talk you through who Ocean Infinity are, what we do, and what we propose to do moving forward. So tonight, Mike and I will discuss the challenges that we face as an industry when trying to push the limits of what is technically possible when using uncrewed vessels offshore. I guess at this stage, we can all agree that uncrewed and lean crewed operations are going to be a big part of the future in our industry, especially given the benefits that they bring. And tonight's a perfect example of that. But there are further steps required to really make advanced uncrewed operations a reality. At Ocean Infinity, we're certainly ambitious with the scale of what we're setting out to do, and that requires a realistic yet comprehensive approach to the challenges we face. So for those of you who don't really know who we are, I'll begin by providing a quick overview of Ocean Infinity. We have been operating since 2016, primarily utilising fleets of AUVs and more recently USVs to conduct survey and data acquisition projects for a range of clients across the globe. This ranges from large-scale hydrographic mapping to search and salvage projects in thousands of metres of water, and you may already know that some of our campaigns have made international news. So over the past 3 months, Ocean Infinity, the group, has almost tripled in size with the acquisitions of both MMT and Abyssal. These two new companies, now within the group, bring years of experience in market-leading data analytics, digital visualization and interpretation, simulation and data delivery to our current offering. And we're really excited to be building such a forward-looking technology-focused brand. So how are we going to take this even further forward? 2 years ago, we decided to take what we had learned from our experience in uncrewed systems and further commit that to really exploring what can be achieved with the most innovative use of technology and then implement that to the maritime industry. Now, USVs are no longer new technology. They've been around in the market for a while through ourselves and through many of our friends at Fugro, X-Blue, X-Ocean, and some are being utilised on a large scale. These sub-15 metre USVs, excuse me, are currently operated safely, efficiently and effectively, and the requirements for legal and acceptable operations are now pretty well defined. However, there are certainly a limit to the current USVs on the market in terms of size, speed, scale, and more so their capability. I don't think the other operators will mind me saying that even we at Ocean Infinity are limited with what we can offer our clients with the 8-metre USVs. So to really push remote technology forward, we at Ocean Infinity are building a fleet of larger robotic ships ranging from 21 metres to 78 metres in length. And this fleet of vessels is called Armada. These new vessels will operate on an uncrewed and lean crewed basis with over-the-horizon technology and reliant predominantly on SATCOMs. The first launches are scheduled for later this year, with all 17 vessels to be operational by the end of 2023. Very ambitious and very large-scale robotic technology. It's worth noting that these will be proper ships. They will be fully classed, flagged, and assured as such, capable of crossing oceans and providing a true replacement for existing conventional offshore vessels in a wide range of roles. And I'm sure you'll agree at this point that this definitely represents a significant shift in the capability of uncrewed vessels. But our ambitious approach will bring with it some pretty big challenges. So I'll now pass over to Mike, who will discuss some of these challenges, the marine regulations we need to overcome, and the data handling from the Armada fleet itself. So from me, thank you.
Thanks, Shabnam. So firstly, I want to start by discussing the way in which specifically the marine regulations have to be approached when dealing with such a radical change in both vessel design and setup, but also the method and mode of operation. For the purposes of these discussions, it's important to understand that here at Ocean Infinity, we'll be operating these vessels as remote control, not as autonomous craft. They will have various autonomous and automated behaviors when needed, for example, in the event of loss of communications or critical failure. But they will be supervised and piloted in real time by qualified mariners 24/7. Therefore, I've framed the challenges and mitigations in the context of remote control. The Armada ships were custom designed from the ground up. With an uncrewed vessel, so many things are required in the design phase, but working closely with both our shipyard and DNVGL, we're constructing the vessels fully to class that is being verified at every stage as with building a conventional ship. In addition to this, they'll be flagged in the UK rather than holding a flag of convenience. We have world-leading robotic and maritime industries here in the UK, and we want to leverage those as much as possible. This means that we have to satisfy UK flagging requirements, and the Maritime and Coast Guard Agency have been hugely helpful over the last 2 years and will continue to be so to make sure that we comply with both flag and coastal state. There's no such thing as a remote or uncrewed vessel certificate yet, so we have to rely on these flag and class requirements to guide us. As part of this process, we've obviously done a deep dive into the regulations alongside the MCA. We've gone through a series of acceptance criteria, overall safety cases, and this has given us an operational and navigational procedure that covers uncrewed command, control, observation, and piloting. We've worked to show satisfactory evidence at every stage, and we will launch these ships with equivalency to conventional regulations. This can then be assessed on a regular basis or project by project to ensure that standards are fit for purpose ahead of the release of what we assume will be more formal legislation for remote vessels in the future. So that shows how minimum standards can be met for the vessels themselves and to make sure that they are safely operated and navigated. The final piece of the puzzle is that of the marine personnel themselves. We're finding that the easiest route to the equivalency certification I mentioned, and therefore legal operations of these larger ships in an uncrewed capacity, is to use qualified mariners as vessel pilots, especially until the legislation has caught up with the technology. So that means to pilot one of our 36-metre vessels, for example, we have to use a mariner and a master who has the tickets corresponding to the size and tonnage of the vessel. Likewise, conversations around DPOs and other support roles are taking place in a similar vein. But there is an added level of complexity when non-normal operations are required. Simply put, Anything beyond normal sailing and piloting of a vessel requires further consideration. Deployment or recovery of equipment, ROV operations, survey work, these all demand additional focus and procedure to take place remotely. Even beyond this, off-nominal failure modes, automated emergency response behaviors, and later, that roadmap to autonomous operations I mentioned, present yet another list of requirements and challenges. As with basic regulations, there are very few formal requirements to guide us, and therefore we are relying on guidance notes from the likes of the MCA, Maritime UK, IMCA. These provide us with a sensible and independent regulatory regime to operate within, albeit an unofficial one at the moment. So we rely on case-by-case risk assessments, as I mentioned, as well as complying with client standards and demonstration of a thorough understanding of project requirements. In turn, this is all linked back to the flag and class equivalency I mentioned earlier, and generally it all leads to the safe performance of tasks offshore. This process is made a little easier for us at Ocean Infinity because we're building our vessels to the standard required to carry personnel if needed. We do anticipate that lean crewing will be required for some of the more complex tasks that we carry out in the early days of the fleet. But building all the Armada ships with things like 2 independent radars, ECDIS units, conventional navigation equipment, and things as simple as fire suppression systems gives us a much easier route to that class and equivalency that I was talking about. Our first purpose-built control center is currently finalizing fit-out in Southampton on the south coast, and will be ready in advance of the first vessels being launched. Now, huge effort is going into providing the most robust, redundant, and secure link to each vessel. I don't have time to go into all the details today, but the focus on both physical and cybersecurity is paramount. Topics such as retina scan access for pilot control, multiple backup comms and power systems, off-grid utilities in the event of a power cut in Southampton, all of these things are being discussed as part of the scrutiny that we are under as we work to make the Armada fleet a reality. As part of the flag equivalency, in some cases, the remote control center becomes an extension of the ship, demanding the same level of regulation and oversight by bodies such as the MCA. This is in itself its own challenge. But as regulations and technology move forward, we want to set new standards for the safety of uncrewed offshore operations. And this means working with operators, governing bodies, and the legislative organizations to ensure that uncrewed and remote technology can be used on a wide scale. So a stepped approach towards fit-for-purpose guidance has to be a priority. As these larger robotic ships are launched and become more commonly used, we will learn more about their strengths and their weaknesses, and we'll continue to work with industry partners to push the tech and legislation forward. Moving away from the regulatory environment for a minute, the other major challenge when considering the remote nature of what we're trying to do with the Armada fleet is that of data transfer, communications, and of course, satellite bandwidth. Initially, we'll be capable of working with support vessels, guard boats, local networks, even GSM capability, and IP radio mesh links to give redundancy whilst we build up our capabilities. True over-the-horizon and SATCOM's capability will follow after the testing and proving phase of each vessel. And, we have the advantage of larger vessels capable of carrying multiple large satellite domes. Even in the most basic sense, this gives us more bandwidth than smaller USVs owing to a larger satellite dome, bringing the idea of full spread connectivity and control very much into reality. There are still challenges and significant efforts have had to be made on these topics. Now, as you would assume, our first priority has to be with vessel command and control, maintaining an adequate visual watch and ensuring safety of navigation. These are legal minimum requirements, and true real-time communication between the onshore mariners and the vessel has to be maintained at all times. So this bandwidth link covers vessel systems, the cameras, the scanners, the radar, the positioning equipment, and has the fallback of multiple satellite bands to rely on in the event of a partial failure of either hardware or software. During ROV or other deployed vehicle operations, this priority link can be upscaled to include the vehicle piloting and feedback to allow onshore ROV pilots and operations to work effectively. Now, at Ocean Infinity, we're working with a number of leading partners, some of whom are here tonight, to work on something that we call dynamic bandwidth prioritization. This gives the ability for us to segregate those minimum requirements I mentioned before across each of the domes and satellite bands we have available. We can then work in tandem with a hierarchy system depending on individual mission requirements, because no two remote missions are the same. Each campaign we carry out will have different priorities when it comes to survey data. We know that the live appraisal of things like data coverage during acquisition is critical to verify adherence to scopes of work in terms of coverage, resolution, hit count, but also to provide real-time information about the status of assets themselves and highlight areas in need of additional investigation. Therefore, we've devised some automated processing steps in-house to provide things like low bandwidth evidence of data coverage, for example. It's worth pointing out that our experience of AUV operations has helped a bit here. We've got a huge amount of experience harvesting various information from our Hugin AUVs over a remote acoustic link, and therefore that makes the jump to SATCOMs a little bit easier. So having so much experience in handling massive data sets from our deep water operations really gave us a great starting point for planning how we're going to achieve a workable setup with Armada. So for the survey data sets themselves, we can apply a number of similar automated offshore workflows, depending on the sensors being used, to engage in some pre-processing before a human has ever seen the data. All raw data is stored on the vessel itself for full download and archiving during port calls, but we aim to bring back as much pertinent information over a remote link as possible to enable both effective operations and QC of the data itself. However, as you know, there are some data sets that are simply too large to transmit back to our remote control centers in their entirety. Therefore, we're working hard on data compression and packaging, and we use them where possible to provide things like heartbeat updates and regular data snapshots. We can bring back pre-processed geotiffs or transverse profiles at preset regular time intervals. These can be altered and set depending on project requirements. This allows regular checks and quality control to be performed by the online team in the remote control center, exactly as they would if they were offshore. And all the data is sent back with required telemetry, navigation information, and all other factors required to allow a proper assessment of quality to be made. But we do appreciate this still doesn't allow 100% confidence in the data quality to the same degree as it would do if you had a client representative offshore standing over the shoulder of a geophysicist or surveyor or an engineer on a daily basis. Therefore, we've also worked to build a comprehensive sensor monitoring package. Now, this is capable of providing quantifiable quality updates for each sensor in real time. Through the use of advanced data analytics, we can assess, monitor, and report whether each sensor is in or out of the scope of work. We can then trigger alarms when individual data sets fall out of spec and highlight areas of potentially marginal data for greater investigation. We can then retask that bandwidth prioritization I mentioned before to bring back larger or more detailed sections of particular data sets for discussion between clients, stakeholders, and the team on shore for a proper appraisal of the data. We can then retask the vessel to acquire additional data if it is deemed to be substandard. As Shabnam mentioned at the start, the Ocean Infinity Group recently acquired Abyssal, who are known for their 3D visualization, simulation, and digitalization capabilities in the subsea market. Now, with such a step change in operational capability, we appreciate that our particular brand of remote capability and operations will need careful scrutiny, not only from regulators, as we've already mentioned, but also operators, developers, and other stakeholders as well. It's understandable that the complete remote and uncrewed operation of a large ship near third-party assets and within energy fields may make some people nervous. And we know that it's our job to prove that we can operate our fleet in the safest and most efficient way possible. So using Abyssal's advanced 3D simulation technology, and by integrating with their proprietary technology stack, we can now practice elements of remote missions as simulations before real-world operations take place. We can simulate a whole campaign with a modeled version of real subsea infrastructure and a virtual Armada ship. Or we can use a partial simulation to test real procedures for complex tasks while our vessels are offshore, but before enacting them for real. This advanced technology allows testing of deployment, recovery, command and control, and things like emergency response scenarios, DP runoff, etc. Even beyond this, with the improvement in digital accuracy, artificial intelligence, and virtual reality, we're rapidly arriving in a world where full digital twins of structures can be produced from simple data sets, all acquired, hosted, and managed remotely. This enables asset owners to model and predict required maintenance and repairs, reducing lifetime ownership cost and improving uptime. And I think in a world where margins are becoming ever more squeezed, this has to be another reason to explore the virtual and simulated world alongside remote operations. Now, I've talked about some of the significant challenges both we and the rest of the industry face. But before we finish and open up some questions, I want to just quickly shift the conversation to what happens next and how we can work to break through some of these communications constraints that I've mentioned. Now, we're already working on some complex simulations for satellite command, control, and data transfer at our facility in Southampton. And the COVID delays to our fleet have enabled us to learn even more about the setup as possible ahead of vessel testing. But as I said, by combining both physical and simulated parts of this setup, we're able to test different prioritization modes and failure scenarios and really begin working on improving the volume of data that can be transmitted in true real time. Now, I said we'll be using support vessels for some projects to begin with, in part to satisfy regulations as we prove ourselves, but also to give some redundancy in communications capability should we require it. As we launch the first vessels later this year, these support vessel trials and operations will help form a proof of concept for genuine over-the-horizon working in 2022, and will give us the chance to trial different setups whilst acquiring proper data. We're investing significantly in further technology and techniques to improve data compression, and one of the key things we're working on is to understand where the greatest improvement can be made for the least effort. Changing one small element of the data transmission may not reduce the usefulness of the information arriving in the remote control center, but might make a vast difference to the transmission and the transmissibility of that data. And dynamic control that can utilize bandwidth differently on each individual survey line could be used to bring back information at different resolutions, or different update rates, or even for different data extents. As the industry shifts towards a more remote and robotic business model, client and stakeholder flexibility on all of these topics will help this technology move forward faster, as Matt was saying, and more effectively than expecting these new techniques to easily fit into existing contracting models. The truth is, as we've heard, with a move towards a data as a service style contracting model on suitable projects, the onus and risk falls on us as a contractor. And should data sets not be compliant with requirements, that's our fault. However, it will allow us to structure and run data acquisition in the most efficient and cost-effective way, whilst maintaining the highest possible standards. Now, we appreciate this isn't practical for all projects or all campaigns, we realise that, but we are looking forward to exploring how it can best be applied and which projects are really capable of benefiting from that model. So thanks for your time this evening. Ordinarily, I'd be looking forward to discussing this with you in the bar later, but I think I've left some time for some questions. So back to you, Simon.
Fantastic. Thanks, guys. That was really very interesting and a good insight to how you're developing down in Southampton and how the fleet's developing. And it was really useful to excuse me, hear what challenges you guys are facing and how you're moving forward with things. I must admit, from my side, I keep saying unscrewed this evening instead of uncrewed. I must apologise for that, and hopefully
feeling a little unscrewed, if I'm honest, Simon. So that's okay.
Hopefully not many more people who have reminded me about it have noticed. Okay, we've got some great questions for you guys. So first of all, one from Matt Garrett, who presented first off. Do you think the regulatory process will conclude in time for your first delivery?
Yes, I think it will be a stepped approach, to be honest. So as I mentioned, probably for the first quite a while, we'll be operating with a support boat within line of sight control, and this will enable us to kind of take that stepped approach to the regulatory compliance. So we're certainly hoping that we certainly know that physically we'll be able to operate them uncrewed from day one. Whether or not we will actually be able to legally is still being discussed, but we will certainly have that support guard vessel within line of sight control to look after the regulatory side of things. What we're hoping is that we won't be reliant on that guard vessel for any element of the operations, and it simply will be there as a box tick on a risk assessment form. But largely that is in the hands of the regulators and clients, for that matter, because a lot of the regulations, particularly in and around energy fields, are set by the operators themselves. So we're asking and discussing with clients, as you know, Matt, to kind of engage with as many as we can to ensure that we are as legally robust as we can be by the time these vessels launch in the autumn.
Okay. And I guess a second part to Matt's question, what level of testing do you envisage before you can go live after the first vessel delivery?
Ask me 2 weeks after the vessel's delivered. No, I'm kidding. I mean, I think the reality is we're not quite sure, because, you know, as with new vessels, we're hoping that they'll be delivered completely seaworthy and sea trials will go smoothly. But of course, we're not only testing a new method of operation and a new way of communicating and transferring data, but we're testing brand new vessels as well. So the testing phase will probably be significant, because we'll have to do acceptance testing of them as boats and ships first, and then move on to testing the uncrewed and remote nature of them. We're anticipating being able to offer commercial services by Q1 2022. So we take delivery in the autumn, so somewhere in the order of 3 or 4 months, I would think, Matt. But if they go really well, then we'll press them into service as soon as we can. But we're not going to rush things, because we know how complex what we're trying to do is, and we certainly don't want to go off half-baked.
Yeah, certainly. Okay, well, thank you for that. I've got a question from Alex Johnson. How do you see AUVs or ultra long range AUVs that can perform port-to-port operations being incorporated into remote operations?
I think it's a good question. I mean, certainly the AUVs that Ocean Infinity operate, our fleet of Hugin 6000s, we're looking to deploy and operate those from the Armada vessels in time. Certainly probably from 2023, we'll be able to deploy and recover those AUVs. So we'll use them as we do now for deep water search and salvage, deep water pre-engineering surveys and pipeline inspections. With regard to ultra long range AUVs, I must confess I'm not hugely familiar with them. I know that Kongsberg made some announcements recently about their endurance models, and I think, to be honest, they're going to be great, but only for certain things, because of the positioning accuracy over such a long deployment. They're going to be useful for certain things, but for really detailed, high resolution, accurate surveys that rely on positional updates, unless you can provide those positional updates regularly enough, then the INS system is going to lose some of their accuracy. So I'm sure that, you know, port-to-port AUVs are going to be fantastic, but probably for surveys and investigations not requiring the highest level of positional accuracy, unless you can provide those updates.
Okay. Okay, a question from Chris Hammersley. How do you plan to interact with other vessels in the area of operation with regard to safe navigation and deconfliction?
In the same way that conventional vessels do. So because we'll be driving these in real time, you know, they'll be piloted from Southampton. They'll be piloted by qualified mariners who will be sat in a pilot's chair. They'll be surrounded by wraparound screens. They'll have exactly the same displays as they would have offshore. You know, they'll have radar, they'll have AIS, they'll have radio links, you know, on a VHF basis to other vessels in the area, to VTS traffic, in the same way that you would do offshore. So we're anticipating interacting with vessels as if we were offshore. We're recreating that environment. We're just recreating it in the control center rather than on the bridge of a vessel at sea. So we're not anticipating too many differences, if I'm honest.
Okay, that's interesting. Finally, we've got a question from Vern Nathan. Vern says, technically, there's lots of challenges that are being overcome to meet the class, operational comms and safety standards. Are the larger robotic Armada vessels running marine diesel engines, or are they all electric?
So the 21 and 36 meter vessels are diesel electric hybrids. So they are diesel engine, but they have significant battery capability on board and battery packs to allow us to do things like peak shaving, to run some of the equipment from batteries, and also to provide a certain amount of silent running for pilotage in and out of port. The 78 meter ships initially will be diesel electric, because they're being built now, and that's the best technology available today. However, they have the ability to be retrofitted with future fuel technology. So we're currently thinking that green ammonia is the most likely future fuel that we'll probably get involved in to provide genuine zero emission vessel operations. But they're also capable of being retrofitted with hydrogen fuel cells or whatever the fuel of the future might be. So certainly the fleet is being built with half an eye on what's going to be happening in 5 or 10 years. But initially will be diesel electric hybrids, correct?
Super. Well, thanks for that, guys. That was really interesting, and I'm glad we got a few questions in there at the end as well. So it's really appreciated, and thanks again for joining us. And we hope to see you again in the near future.
Yeah, thanks, Simon.
Thank you.
Cheers, guys. Okay, so we've got 4 presentations this evening. Our third presenter this evening is Simon Waterfield, Survey Support Group Manager at Sonodyne. Have we got Simon there, Duncan? Hi there, Simon. How are you?
Good, thanks. Yourself?
Good. Yes, we're all fine. You're coming in loud and clear now.
That's good.
So I'll just introduce you. So Simon has worked in the offshore survey industry for over 25 years, working for a variety of construction and hydrographic companies. Simon joined Sonodyne in 2015 to manage the survey support group. Most recently, the focus of the survey support group has been the rollout of the next generation INS and LBL software, Fusion 2, as well as establishing remote operational survey support capabilities within Sonodyne. So Simon's presentation this evening is entitled how manufacturers are responding to the growing requirement for remote training and remote operational support. So over to you, Simon. Thank you.
Yeah, thanks, Simon, for the introduction, and thanks for inviting me along tonight to give a presentation. So it's quite a long-winded title, but basically just going to sort of talk you through what Sonodyne have been doing to sort of still maintain the high levels of service that customers have been expecting from us, primarily focusing on training and operational services. So remote training, go back and look at how we actually conducted most of our training courses up until March 2020. So we've always delivered face-to-face training to meet our customer requirements. We've been doing this for many, many years, and probably for the last sort of 10 to 15 years, we've had dedicated training teams that have gone around the world to deliver these training courses. They've always very much been focused on hands-on experience. So we like our customers to get their actual hands on the equipment, do the interfacing, some testing on it, get a feel for it, plugging it all into the software, and all those kind of things. So we did that in sort of 5 main ways. We've got our trials and training facility in Plymouth in the UK, where we do most of our training. We've also got the head office just outside London, where we run training courses. And we've also got our regional offices in Aberdeen, Houston, Brazil, or Singapore, where we run courses. We can also go to the customer premises to deliver courses there as well. And we can also pretty much go anywhere in the world to deliver courses. We've delivered in water training in China, in Houston, Brazil as well. And we've also actually go out onto vessels as well. You know, we've sent our training teams out onto drill rigs, construction vessels, things like that, to actually do the training in water on site. So this is down in Plymouth. We've got a couple of vessels down there, Echo Explorer and Sound Surveyor, and we have an array under the seabed, on the seabed underneath the marina there. So we can do all our LBL training there, we can do USBL training, INS training, any kind of training on a product that Sonodyne manufactures. We can conduct that using our vessels in the arrays down in Plymouth. We've also got an office down there as well, so we can use that for doing sort of training courses in the classroom. And as I said, we can always go sort of all around the world delivering training as and when required. for customers. So I'm sure, as you can pretty much guess, a lot of that changed in March 2020. Like everybody, we suddenly went from being able to fly around the world, delivering our training courses, to basically not being able to do any of our face-to-face type stuff. So we had to come up with new ways that we could deliver our training to customers while still trying to maintain, as much hands-on approach as we could possibly deliver to our customers. So from visiting customer premises and doing some of our training courses in remote offices and things, we already had developed a lot of simulator tools to enable us to deliver training to as good a standard as we could without being in the water. So we have a lot of in-house simulators. We have our 6G acoustics simulator. So within here, again, we can put in any kind of beacon, underwater positioning system, transceiver, sound velocity sensors, anything that we sort of generally manufacture that delivers acoustics, we can simulate that within our simulator. We also have other tools that can generate output strings, so we can generate GGAs, depth strings, ZDAs, PD, DVL strings, things like that. So again, that was another tool that we already had available to us. And we also had our INS simulators. So this is what we call a Lodestar Zero. So we developed these quite a few years ago for our in-house software engineers and developers to be able to test our software without physically having to have an INS unit. When I went around the world sort of doing Fusion 2 technical workshops and demonstrations, I took one of these units around with me to enable us to simulate INS data. So it saved us a lot of hassle, and the training team, took this on as well when they were visiting customer premises or going to regional offices. They would take these along with us, and it would enable us to simulate INS data. So this has about sort of 4 days worth of actual IMU data that was recorded in a static scenario. It has all the same connections on it that a real Sprint INS system would have. So, we can very much simulate exactly our INS systems into our software. So we had a lot of these tools already in place. The only thing we didn't really have was a mechanism to deliver these things. Luckily, when the pandemic came along, a lot of system providers came up with a lot better solutions to create webinars. Similar to what we're doing tonight. There was a lot of tools that were developed quite rapidly to enable much better webinar experiences. So we investigated quite a few of these, and the training team decided that Zoom was the best platform for us to do that. At the time, when we were looking at this sort of just over 12 months ago, Zoom was sort of definitely the best developed. It had a lot of interactive tools that we could use. We could put presentations on the screen, and there was a lot of interactive tools that customers could, draw on the screens and sort of interact with us and stuff like that. And one of the key things that it offered was the ability that we could share the trainer's mouse and keyboard with our customers, so they could actually still take control of the software. So this was giving us the best opportunity to, as much as possible, keep hands-on sort of training with our customers. So this is one of the training courses. We've got a trainer in the top right-hand corner there, Stu, with a customer, and at this moment he's delivering Fusion 2 INS training. So, we take the customer through, exactly all the scenarios that they would have done had they visited our facility down in Plymouth, other than, actually physically having all the equipment in the water. This was all simulated, but, we're able to let them take control of the software, guide them through what they need to do, and give them that hands-on experience. We've migrated all our core training courses into an online course. So Fusion 1, Fusion 2 courses on the LBL side of things. We do Fusion 1 to Fusion 2 LBL top-up courses, Fusion 2 INS and SLAM courses. So basically most of our core products that we used to do our training on, we've now migrated those into an online course, all the way through to our USBL Ranger 2 systems, Mini and Micro Ranger 2. We can also do our Sentinel training, which is our sort of maritime security diver detection products. And we can also do customized training as well. You know, it's much easier actually to do some of that online. It's easier to sort of modify the training rather than sort of doing that in person. So that's actually one of the benefits of doing the online training. Is actually slightly easier to customize it for customers. So what we've delivered to date, we started off fairly light bandwidth with doing some free webinars just to get our training team familiar with Zoom, how it can operate, what kind of interaction we could generate with customers. So that gave them a good basis to help sort of migrate the training courses online to sort of see what kinds of interaction and things we could do. And then we actually started running online courses in June 2020. To date, we've actually delivered 383 remote training sessions. So if you saw on the previous slide, a lot of our courses are made up with multiple modules. So basically at the start of the course, before the course starts, the training team will send out a lot of reading material to the customer so they can sort of prepare, get a bit of background reading, all that kind of stuff. Then they will generally start off with a group session, and we can take up to sort of 6 people within that group. But as the course then migrates into the further modules, the more detailed modules where you get hands-on to the software, we run those as dedicated one-to-one sessions. Again, you know, we want to give the customer as much experience, as much hands-on use as they can with the software. So that's best done, you know, on a one-to-one basis. So that number of 383 isn't complete training courses. That's the number of actual sessions that we've carried out. And we've done that all over the world. You know, people have been at home. A lot of companies have been taking advantage of people being in quarantine, either as they arrive in country before they start a job. They've had to have quarantine periods in hotels, so we've delivered training courses during those quarantine periods. And at the same time, you know, as they come back to their country of residence, we've been delivering training in quarantine there. So our customers have been, you know, very good at sort of making use of some of this sort of trapped time, you know, still getting some use from their people and sort of still training and educating them as they go along. So it's been quite a sort of hectic change for the training team, but you know, we've adapted pretty well. The courses are a lot more intensive to deliver now. You know, beforehand we could do a whole sort of course for 6 delegates. They could arrive in Plymouth, do the training course within a week, and then go away, job done. But obviously trying to get through that number of people with individual one-to-one courses and sessions, it's taken, you know, takes quite a long time to get through. So, you know, they've been pretty much sort of fully booked for the last 6 months or so, doing all these training courses, and we're pretty fully booked going forwards. But the big advantage that this gives us is it gives us more flexibility with the training. You know, you now haven't got sort of set specific dates where you have to book, arrive in Plymouth, do the training course. You know, we can be much more flexible now in how we operate it. So that's the kind of remote training side of things. The other aspect of what we deliver is on the remote operations. So this is kind of different to remote support, and there is a distinct difference between doing remote operations and doing remote support. Like the majority of manufacturers out there, you know, Sonodyne has a 24/7 remote support team to assist our customers. We've had that for many, many years. You know, customers can phone us 24/7, they can send emails in, and we provide them with remote support, either via email, over the phone, or we have sometimes had the ability to dial into our systems depending on what the customer requirements are. Like most people, we've also had the ability to send field engineers to vessels for installation, repair, maintenance, upgrades of our systems, and all those side of things. And within the survey support team, we've also sent surveyors out onto vessels and to sites to provide operational survey services to customers. So this could be where they're testing new software, testing new techniques. They haven't got enough experience in-house to be able to do it. We would send our surveyors onto the vessel and basically assist them with their operations. Obviously, again, you know, sort of 12 months ago, that whole sort of level of service just died. You know, we couldn't send people out onto vessels or sites anymore. It proved very difficult to do that. So we had to look away to maintain or regain that level of service that we were delivering to our customers. So that's been sort of prime focus of us over the last sort of 12 months is what can we do to deliver operational services remotely. So we were looking at obviously taking our personnel from offshore, you know, linking our systems up to satellite communications and things, transmitting streaming data, however, back to their office or home, where our surveyors would basically take over or supervise operations offshore, much in the same way as we would do when we were physically out there on the vessels. So the key for us and our customers was a way to provide secure communications. For ourselves, you know, we needed to make sure that our IT infrastructure was secure, and also for our customers on the vessels that we were maintaining the security of their IT systems. And we have to cover a very wide spectrum of use cases due to our varied customer base. You know, we cover the energy sector, we cover the defence sector, we cover the science sector. So we have a very wide spectrum of people. So we had to make sure that whatever means we used to dial into our systems, you know, it was secure, and you know, there wasn't going to be a disruption to those communications, and obviously wasn't sort of susceptible to any kind of cyber attack or anything like that. So we came up with what we call a ROAM box. So that's a remote operations access module. So previously, customers would tell us where and when they would like our surveyors to travel to. Now with ROAM, customers can tell us where they want us to ship the ROAM box to, and then give us 24 hours notice for when they would like our surveyors to connect to the system and either supervise their operations or take over some of their operations. So ROAM uses an online portal via a secure VPN internet connection. It uses commercial 256-bit AES encryption decryption. It essentially connects the Sonodyne system to the internet, and we can use either cellular data, Wi-Fi, or we can use the vessel SATCOM system. The customer needs to grant us access to the internet via there, so they can use their client network, or you know, open up their firewalls and things to do that. Because some of the instances when we were doing remote support in the past, we found it was quite difficult to actually connect to our machines due to various firewalls and things like that. So it has an intelligent router within it, which automatically swaps between either network connection, Wi-Fi connection, or cellular connection. We can also create a client portal, so our customers can actually directly access the Sonodyne systems via ROAM as well, if they want to. And again, this is run by a slightly different team within Sonodyne than the customer support team. But in certain circumstances, you know, the customer support team may be able to use ROAM to actually diagnose any equipment hardware issues or software issues much faster than the conventional telephone calls or emails or sort of traditional methods that we would have used. So it's got multiple uses. And as I say, we can pretty much use this to connect to any piece of Sonodyne software or potentially Sonodyne hardware as well. So it's very simple to set up. It's all contained within a single sort of ruggedized case. Literally provide power over Ethernet, 24-volt power outlet to it, connect it to the ship's LAN if it's available, and then plug it into the Sonodyne network on board the vessel, which will be connected to Fusion 2 PC, for example. It can directly Ethernet connect to our SprintNav systems or our Sprint systems as well, and we can connect to our interface hubs that we have on the vessels as well. So it's pretty easy and straightforward to set up. It's just a view of the online portal that we log into. So once we get into the portal, we can see the number of boxes that we have, when they're active, when they were last active. The ROAM box does have a GPS antenna in it as well, so if we do get GPS signals, we can actually see where the box is and where the vessel is as well, which can obviously be useful in certain circumstances. Within the portal, we can, monitor usage. There's various sort of things in there. It's got event logs in there, so we can see when our surveyors are logged in and out of various different systems as well. So it gives us sort of full traceability of the times that we were logged in and out, and of the data that we use whenever we're doing any kind of operational support. What we've delivered to date so far. So we first carried out our first sort of remote survey service in August 2020, and to date we've run 37 remote sort of 12-hour shifts. So this is very much the same as when our guys would go onto the vessels. We go onto the vessel, they run a 12-hour shift, and they're available. If operations need to go on longer than 12 hours, then we can just make another surveyor available to cover 24-hour periods if necessary. But this is very much on a pre-arranged sort of schedule. You can't just phone us up at 3 o'clock in the morning and say, I want you to run a 12-hour shift now. Because by default, we don't have our personnel running 24/7 shifts when they're at home. But if you give us notice, we can make sure they're rested enough before they start their shift, and also when they finish their shift that they get rest before, they go back to their normal day job. So, it does take a little bit of planning, but obviously nowhere near as much planning as physically sending people out onto the vessels. So a bit of a summary, it saves money, gives greater flexibility, and obviously we're not sending people around the globe, so it's helping companies to reach a lot of their net zero targets that they've had. Obviously it saves money, because usually if we send people onto a vessel, they might only actually end up working for 2 or 3 days while they're on the vessel, but due to operations they might have been out there for 2 or 3 weeks, and obviously customers are paying for our people while they're on the vessel. So sometimes it would actually detract customers from taking our people offshore, because they would have to be there for the whole duration of an operation. Whereas now, if you've got a 3-week, 4-week, 5-week trip, but you only actually need the sonodyne support for 2 or 3 days, we can now just do that 2 or 3 days, because we're not physically on board the vessel. We can dial in when we're needed, and then, we can get on with our day job when we're not needed. We're not having people sort of stuck on vessels anymore. So that's basically a summary of what we've been up to try and sort of carry on maintaining the same levels of service to our customers while we've all adapted to this new way of working. Try and just sort of leave a few questions out there. I know hopefully you've got some questions for me, but we've got also questions out there to the community. It's a whole new world for us. Obviously before the pandemic started, we were seeing a lot of remote operations. Remote operations are still going to carry on forward. We're already getting some inquiries as to when we were going to start face-to-face training again. When are we going to start sending people out onto vessels? We have still been sending people to vessels to do service visits and things like that, and we've got somebody going out to a vessel in Las Palmas next week. So we are still doing that, and we're still seeing inquiries from it, but, we're going to run things in tandem. We're not going to suddenly say we're going to stop doing this or we're going to stop doing that. But obviously it's good to get some feedback from the industry as to whether they see the future carrying on with remote training. Are we going to see more people coming back to our training facilities? And if we are going to carry on doing a lot of the remote support and services that we provide, it's slightly different to the services that likes of Ocean Infinity that Mike and Shabnam were talking about. We are supporting those customers. We're not providing the full-on services, but we are dialing in and helping them do these kind of things. And at the moment we are doing it purely by remote desktop. We do have some remote control capabilities within our software, but we haven't developed that yet. Some customers we talk to and they say, oh yeah, well, bandwidth is fine. It's so cheap now to get decent satellite bandwidth that we don't need a lot of these, high-tech systems to stream data, all these remote APIs and things like that. A remote desktop works fine for us. So, it's good to get some guidance from the industry about how they think, they want to get support from us as a manufacturer to help them develop whatever systems that they're going into. And I think it was mentioned a little bit earlier on in some of the questions, do we need a standard data exchange format? If we are starting streaming data from offshore to onshore to sort of drive a lot of digital twins and things like that, is it better that we get in there early and try and, come up with some standard formats of how to transmit that data? And ultimately, at the end of the day, you know, we've got to have a look at, you know, does it give us the same, better or worse performance? You know, we've already picked up on a few things. You know, when we're out there on a vessel, you know, we get familiar with the setup, you know what the connections are to other systems and things like that on the vessel. If we're just dialing in remotely, you know, we only get certain snapshot or certain visibility to what's going on at that time. You know, so the spatial awareness of not being on the vessel sometimes takes a lot more sort of digging to find out some of the problems, you know. And we do provide sort of checklists and things that we send to the customer to sort of fill out before we start our remote service, just to sort of try and get a feel up front for, you know, how the systems are configured and what the operations are that are going on and things like that. So that's just a few of our thoughts and you know, how we've been supporting our customers. So that's the end of my presentation. Thank you very much for your time, and hand over for some questions.
Super. Thanks, Simon. That was a great insight into what you guys have been doing, you know, and how you've been providing remote training and remote operations. So it's really interesting to hear a manufacturer's perspective as well. So I have a question here from Paul Newman. Do you see the Roam model increasing in use in the future, and what other services could you provide in that format?
Yeah, we're potentially seeing it increase. I mean, you know, it has increased over the last sort of 10 months. You know, we started off just with a smallish investment into it to sort of support our customers, you know, and we have increased our investment over the last sort of few months to gain access to more of these Roam modules to be able to do it. But you know, that's a bit of a thing. You know, the question's out there for the industry. You know, do they see support coming from manufacturers in this remote side of life, or do they still, you know, want us out on the vessels? You know, within the science community, you know, a lot of things are done autonomously, and we use things like Roam to get into you know, AUVs and things like that, to do a lot of data harvesting, data downloading and things like that within the scientific community. So you know, those are the type of services that we already offer through Roam, and you know, it's really just going to be down to what the demand is at the end of the day. You know, we are sort of, say, looking to evolve better, cleverer systems, you know, more autonomous type systems that will, you know, make a lot of this much easier. But, you know, a lot of that gets driven by what the requirement is out there.
Okay. That's interesting. I hope that answers your question, Paul. Question from Alex Fox. Are there plans to offer Roam as a soft license? For example, if the survey kit is already in country and a surprise metrology comes in and there isn't time to organise a Roam shipment?
Yeah, I mean, we can dial into a Sonodyne system via whatever means a customer wants to provide us with. Obviously, then the security side of things comes down to them. You know, how secure is the connection? Are they happy to open the system up, you know, almost to the internet, you know, openly? You know, that's, as we all know, that's a risk. You know, to let any PC connect to the software, to the internet rather. You know, we have used TeamViewer in the past to do remote operations via. So, you know, obviously we take some protocols our side. You know, we'll disconnect ourselves from our own servers and things like that if we are doing it that way, just to give ourselves the added security that, you know, we're not going to get any kind of viruses or things like that onto our networks. And, you know, we would expect customers to take the same kind of precautions. But yes, we can offer the same kind of service at the end of the day without the rental of the hardware. But the risk becomes more down to the customer at the end of the day for the security of it.
Okay. And do you think you would have developed, it was the Roam method, as it were, under development, or was the events of last year and continuing this year a driver to pushing that forward?
It was a faster track mechanism. Things like this have always been sort of under discussion within Sonodyne, and I'm sure within majority of other companies. But it was generally as a lower priority. But obviously the last sort of 12 months has made a lot of people sort of refocus their minds on what needs to be done, and how can we escalate things. So that's why it didn't take us too long to roll these things out, because a lot of the homework had already been done. It was just the pandemic gave us the key instigator to actually put a bit of investment into it now, rather than in a few years down the line.
Okay. Okay, and final question from me. I get a go sometimes. Have you found that you've given more training or less training now you're doing it remotely?
The number of training courses is probably about the same, but as I said, the intensity for delivering them has gone up. Because I said we could, if you imagine 6 customers coming down to Plymouth, we get through all those 6 customers in 5 days. Whereas now, we've got 6 customers, we can do 1 group session, and then we've got to do 5 lots of 5 individual modules after that, which, they're 2 or 3 hours each. So, whereas we could get through 6 customers in 1 week, now it can take us 2 or 3 weeks to get through 6 customers.
Okay.
So if you look at, total number of courses, it's probably about similar. But to be honest, the sort of time it takes from our side it takes longer to get through.
So what's the preference, do you reckon? Are you waiting for that to be customer driven, or are you looking to evolve one way or the other, or either face to face or online or hybrid, or?
Yeah, it's possibly hybrid. I mean, our preference is always to get our customers, their hands on the equipment. We can obviously talk you through schematics and show you plugs and connections and things like that on this kind of a medium. But, when you come down to Plymouth and you do a Fusion 2 INS or a Fusion 1 LBL course or whatever like that, you're physically plugging in the ROV navs, you're physically sort of looking through the compats, and, you're doing all that side of things. And, as we all know, things can work pretty straightforward in a simulator. And as soon as you chuck it in the water, especially in Plymouth, where we have sort of rapidly changing sound velocities and things like that, there's always a certain amount of troubleshooting that goes on during the training courses because of the environmental conditions that we face, and it gives the customers a really good basis for troubleshooting when they get offshore. But we do know that comes, at a cost. It's an additional expense for customers to fly people from wherever in the world to come down to Plymouth to do that. So, I think the percentage split would probably be more in favour of remote training, possibly going forward.
Yeah, okay, that's interesting. Well, thanks very much for your time, and thanks for that insight into remote training and the remote operations from your perspective. It's very much appreciated. Thank you.
No, thanks for inviting me along.
Okay. And next up, our 4th and final presentation this evening is our speaker is Dr. Alison Proctor. Hi, Alison. You coming in loud and clear? Good. Okay, so Alison is the Chief Operating Officer for Ocean Floor Geophysics. Alison has a PhD in mechanical engineering with more than 20 years experience working with autonomous vehicles. She joined Ocean Floor Geophysics in 2015 as an AUV pilot and control systems engineer. She served as program manager in charge of development. She served as program manager in charge of developing the OFG Hugin AUV survey program and is now the chief operating officer for the company. She's run many offshore projects for the company, including OFG's collaboration with the winning JEBCO NF alumni team in the Shell Ocean Discovery X Prize. The title of Alison's presentation this evening is Advanced Shore Support, providing specialist support to offshore AUV operations, data processors and survey teams through low bandwidth satellite communications. Over to you, Alison. Thank you.
All right. Thank you, Simon, for the introduction and also the opportunity to present tonight. So today I'm going to be talking about the advanced shore support for offshore AUV operations and our experience in providing specialist support to our AUV team over vessel-based satellite communications. Now, last year, OFG was asked to conduct an offshore AUV survey. And with COVID-19 limiting the capacity for international travel, we decided to launch a new remote support program to enable specialists around the world to participate in the survey remotely through low bandwidth vessel-based satellite internet, very much like what Simon was just talking about before. So the resulting system that we developed worked really, really well and enabled the completion of the survey with an offshore crew that was composed primarily of people that were domestically available in the country we were working in, and through the support of an array of international specialists. So today I will go through some of the lessons learned from that campaign and finish by discussing our future goals with automated processing and advanced shore support. So remote support, I think everybody used those words in their presentations tonight. This is really advanced shore support systems that we can use to enhance our offshore survey team and provide easy access to shore-based specialists and knowledge bases. And there were a couple of ways that we used remote support on our project. So number one, we had shore-based experts that could assist with short, specialized tasks such as calibration or setting up new equipment. And then we improved the availability of information and knowledge to the offshore teams while they were trying to solve problems. And lastly, we moved administration tasks back to the shore-based resources so that our offshore personnel could be used a little bit more efficiently. Now, the motivation for this work, for us, there was really three main reasons to pursue this objective. First, to reduce the offshore contact hours. So offshore operations are intrinsically higher risk than onshore operations. So minimizing the offshore team can really be used to reduce the total overall project risk. And then further, with a smaller offshore team, it can be far easier to find vessels of opportunity. Next, a globally distributed onshore team is much more flexible than an offshore team that is attached to a boat. So the offshore personnel must be organized well in advance. There's travel, there's restrictions, and they are constrained such that they can really only be changed during port calls. So often you have people on board for far longer than you actually need them. Whereas onshore people can be engaged as necessary with very little lead time. They don't require visas. They don't require extra logistics for traveling. And they can still participate. Now, of course, the main reason that we did it right now was to mitigate the risk to our projects due to the ever-changing limitations on international travel due to COVID-19. Now, of course, that all sounds good on paper, but to make remote support a reality, we needed to use some technology. So in order to have a shore-based team filling a critical role in the project, they need to feel like they're immersed in the vessel operations, even when they're sitting at their desk. And this requires a robust data connection. And so with innovation in satellite communication technology, this is definitely becoming feasible now. And dedicated satellite connections with 20 megabit per second sustained and burst rates of over 50 megabit per second can be achieved today with existing systems. And tomorrow we'll be able to do even better. So this really opens up a lot of possibilities for providing remote support to an offshore team. And to be honest, we were able to establish a pretty robust shore support system using only a 2 megabit per second connection. So there's a lot that can be done once we have that robust pipe connecting the vessel and our shore-based team. But as I think everyone else has pointed out as well, more connectivity also means more IT vulnerabilities. And this can be effectively handled with a satellite network provider that provides some value-added services to help minimize your exposure to network traffic to the internet. Now, for this project, we were very lucky, and there was a dedicated fiber that ran right from the satellite providers to our client's onshore data center. So none of our network traffic ever had to touch the internet. And external users would access the data center first through secure means, and then they were able to access the vessel and our remote support network. So once there's a secure and stable communication to shore, it's still wise to budget your bandwidth well, because this allows you to do more with less. Now, we had excellent success using the ClearComm LQ series IP interface, along with their Agent IC software. So this allowed us to tap into the vessel's existing analog ClearComm system from our remote onshore locations. So this was a great way to provide that immersed experience to our onshore team. And it was extremely efficient on bandwidth and gave us 2 channels of communication with only 32 kilobit per second of bandwidth usage. So, from my desk in Canada, I was able to sit and talk with people. We had meetings over ClearComms. We were able to troubleshoot, just check in, chat, anything we needed to in order to be present on the vessel. Now, of course, one of the other key elements to providing an immersed experience for the shore team is to provide video feeds, right? So you really need to be able to see what's happening in order to know what's going on. And really, there are so many different technologies out there that allow you to do this. There's 100 ways of setting this up. Now, our choice was to use a 4-channel H.265 video encoder and then transmit the image from 4 computer monitors back to shore. So then we would just display whatever we wanted to be sent back to shore on those computer monitors. And then they would get compressed and transmitted. Now, with this setup, we were able to use readily available H.264 IP cameras and still get the benefits of H.265 compression by simply just displaying them on a HDMI monitor. And so our choice was to put up a camera computer on one monitor, and then the other 3 monitors would have mission critical software showing. So we were able to basically see what was going on the deck, and then also track what was going on with the mission progress. Now, once the video feeds were on shore, then they were rebroadcast by a media server. So there was ever only one feed coming from the vessel to shore, and then the distribution happened on shore. Now, we ended up with this system to have an excellent resolution and frame rate on all 4 streams using less than 1 megabit per second of bandwidth. And this really, you felt like you were present on the vessel while you were sitting at your desk and talking to people on ClearComms, watching the software and being able to see people walking around on the deck. It was as if I was simply in an office. So for the then for the rest of the thing that we needed, we added a bunch of collaboration tools. So the first was a chat server. So this allowed us to easily communicate between our onshore and offshore team. And then also we put in a number of bots, which made announcements on the chat server to tell us when things were happening on the vessel, like when backups are finished and data copies. And then we implemented a dashboard as well, which showed all of the relevant information about the AUV, so that someone that knew the mission plan could actually determine where the AUV was and how long it would be until recovery without ever having to say that explicitly or be logged into the video. And our goal was really to make sure that we were freely providing information to the onshore team so that they were not asking questions of the offshore team all the time to be able to do their work. And so these tools really did a great job of that. And then the last kind of two things that we did was to implement a synchronized drive system so that the onshore team and offshore team had a data repository that was always exactly the same and managed automatically, so that we never had to worry about somebody having data that wasn't up to date. And then lastly, when you needed to really delve deep into the what was going on, we had the ability to connect via TeamViewer. And this allowed us to if we needed to get in there and manage servers or intervene with backups or provide like real specialist support for connecting or configuring equipment, then we could do that through TeamViewer. Now, with all of this, there are still roles that must stay offshore, right? So we wanted to move as many of our roles onshore as possible, but some roles just can't be moved. So for example, for AUV, there was a minimum number of people that are required to safely conduct the offshore operations. And there needs to be an offshore manager who's on board the vessel, knowing exactly what's going on, that can keep the operations going on the vessel smoothly. Similarly, you need to maintain a level of quality assurance with the data. So it needs to be a qualified processing and interpretation team. And then lastly, with the introduction of so many new technologies that are in the critical path for the project, there needs to be IT support that can help with things when they stop working. So then what roles can be moved to shore? So the first and easiest one is extra administration roles. So sometimes, especially on big projects where there are multiple companies collaborating, then there's sometimes necessary but redundant administration. And then when the onshore team is properly immersed in the offshore activities, then these extra team leaders can and client reps or whoever can actually successfully work from shore. Equipment specialists that don't have any real data collection functions during the survey can also participate remotely. So for example, an expert could easily manage the Sonardyne calibration or HIPAP calibration from shore using the tools that we implemented. And then lastly, the data processing team. So a full team of data processors is not really required for AUV operations. But how do we reliably produce our preliminary deliverables without a data processing team? Well, this is kind of the last piece of the puzzle that we're trying to solve. And we've done it by creating some automated offshore data workflows. So the amount of data produced by our AV is is just too big to get off the vessel over a satellite connection. So a shore-based data processor has to process the data on the vessel using remote access. And the data processing team can access the vessel through TeamViewer, but trying to operate the data processing software over a really slow link with some latency is not really optimal. So we need to be, and also we need to be robust to network dropouts, where the data processors are actually prevented from accessing the vessel for an extended period of time. So our approach was to automate as much of the process as possible to keep the data processing cadence, even if the person monitoring the data processing workflow was unavailable to press go. And then the second thing was to try and reduce the number of mouse clicks required to do a task. So we partnered with Teledyne Keras to develop a system that could meet these goals using Keras on board and Mira AI. Now, this does not remove the need for a data processing team. We still need a qualified people to monitor processes and run quality checks. But for many types of surveys, this job can be done remotely with these new tools. So using Process Designer and Keras on board, we were able to automatically initiate all of the data processing workflows, and then the data processors spent their time monitoring the processes to ensure that everything was working correctly, rather than clicking next on the workflow. Now, Keras on board actively looks for new sensor and raw data files, and then they initiate a workflow that has been developed through Process Designer. And then the final piece for minimizing the number of mouse clicks is Mira AI. This is the Teledyne Keras AI-based cleaning tool, and we're currently actively testing this tool and exploring all of the ways that we can use it to enable remote processing work. But basically, it allows us to do that task that requires all the fine mouse clicking through an automated process. So with Process Designer, Keras on board, and Mira AI, it is possible to automatically generate all of the onboard deliverables automatically. Now, our experience with remote support was very positive. The offshore team really embraced the concept and attempted to use the new resources to improve our field campaign. Now, enabling specialists to assist remotely helped fill small holes in our team competencies, but you still really need a strong offshore team. Reducing the number of personnel on the vessel means that each person offshore really counts, and they must be skilled at the jobs that they do so that they can perform them efficiently. Similarly, the onshore people needed to be very familiar with the offshore operations so that they could easily integrate into the team without actually being on the vessel. Now, new software and technology developments really, with new improvements in software and security, are required. We were incredibly successful in meeting our conservative goals in this project, but that just left everyone wanting to do the next thing, right? So if this was possible, then what else can we do? But even with all of the success that we felt, it was still clear that there are some limitations, and there are some times and some types of surveys where it's best to have your people on the boat where they can touch something and make it work. And these are areas where people are having to make real-time decisions, and they need to make that decision in order to keep the project moving along. And so there are cases where it's still a good idea to have your people on site, but there's a lot of cases where you can employ these remote processing methods to reduce your offshore team. So for future work at OFG, we're looking to build on this experience by facilitating new cross-discipline survey concepts, enabling scientists to interpret data remotely, to get a more synergistic evaluation without any restriction on the team size due to vessel or logistic constraints. And this program really provided us with valuable insight into developing some best practices for reducing the number of crew offshore, and also for relying on remotely located specialists to ensure the consistent delivery of high quality data products. And this work has also provided us with a technical and kind of procedural framework for demonstrating the remote bathymetry and side scan imagery processing solutions that have been available through Teledyne Keras products. And Keras is continuing to develop the remote processing tools, including a new suite of native web-based software. And this development is going to be part of an ongoing collaboration between OFG and Teledyne Keras that is supported by Canada's Ocean Supercluster. So I'm just going to finish off with this last slide, which just shows all of the contributors in the project that we're doing with Teledyne Keras for enabling remote data processing. And thank you all for listening to my presentation.
Thanks very much, Alison. That's fantastic. It was really interesting. Just for my interest, is this has this been kind of an ongoing project, or is this something that's relatively new, or is it been driven by pandemic, or how has this come about?
The timing was driven by the pandemic. It's something that we had been talking about, before everything started. There was, a lot of support for reducing the number of people offshore, just to mitigate HSE risk and requirement. And so once the pandemic hit, it was, okay, well, we've been talking about it for a while now, let's do it and see if we can keep going to work.
Okay, that's I guess that's been a common theme this evening, that the pandemic has driven a lot of these new technologies and pushed forward a lot of developments. I wonder just as an opinion, I guess, or as somebody who works in the industry, why do you think it takes a pandemic to drive forward the development in technology when the long-term goals of this type of, the long-term outcomes of this type of work have been clear for quite some time, and the technology really is been on the way for quite some time. So why do you think it takes a pandemic to push this forward?
I think change is always hard, and it's easy to sorry, twice. It's hard to take risks and to put money into things when there's not an immediate need. And so it just became an immediate need. So a lot of people, I think, have been thinking about it and were, slowly dipping their toes in, and now it became important to dive in.
Mm-hmm. Okay, that's interesting. Thanks for your views. So we've got a question from Nikki. Are you using personnel onshore that have had previous offshore experience?
Yes, I think everybody that we were using onshore had offshore experience, and that really made it a lot easier for them to understand what was happening on board the vessel.
Okay, I found it interesting. It's an interesting. So how are you working that? You've got, is it that you would have more experienced people offshore and people with lesser experience onshore, or? Sorry, go on.
Yeah, so we actually, our offshore team was very experienced, so that they could handle handle what they needed to if the communications links went down. But the specialized support that they needed, that we kind of left on shore. So we had people that could do the day-to-day operations very well. But if there was like some kind of mechanical failure, then that person would be a shore support. And then we also put our kind of administrative people on shore as well. Party chief, and that was able to be on shore, and they knew what day-to-day operations were like on a vessel because they'd been there before. So they understood how the morning meeting went and how and what questions they had to ask of the offshore people in order to be able to make the whole project work properly.
Okay, that's interesting. Thank you. And with regards to security and infiltration over the airwaves by unwelcome parties and whatnot, do you see that being a challenge in the future more and more, or how do you see that? How do you see the future of security and protecting yourself in the future?
Yeah, it's a big challenge. And, we're a small company, so we have, we rely on outsourcing security, basically. So I'm looking for, satellite providers who can give me that security for my data, or partnership with a client who can do that for us as well. So I think it's extremely, extremely important. I think we've all experienced this kind of disruptions, in operations, and we've never had anything in an offshore survey. But when you've got some small field test or whatever, and you're just out with a couple people, and suddenly you find out that there's a vulnerability there that you didn't think about. So when we're out in the offshore conditions, we're very, very, very careful about never opening ourselves up to any kind of risk from that way, because that's when you least expect it is when people can jump in.
Okay, well, thanks very much for your time. That was really interesting. I wish we could have more time with with you and the rest of our speakers this evening. Really appreciate you taking the time out to join us. Thanks very much.
No problem. Thank you for having me.
Okay, guys. Well, that was four fabulous presentations there. I'd just like to thank all our speakers this evening, and I'd like to thank all our viewers who had so many fantastic questions for us, and just a special thanks to Duncan, who's doing all the directing and producing behind the scenes. So stay safe and enjoy your evenings, and if you're in Canada, enjoy the rest of your day. Take care. We'll see you here next time. Cheers. Bye-bye.